All right, we got some stuff to open, and the first one is called modules. And those are surface mount IC test sockets. These are both for 8-pin chips with two slightly different widths, and they convert the surface mount into a through-hole dip package. So there's pins on the side, and when you push down the socket, those pins widen. You can drop a chip in there, and when you release, it will grab on and hold the chip, make contact, and you can plug this into a breadboard or a programmer or something. So this can be useful, for example, if you have an AT-Tiny85 and you're going to put it on a board that doesn't have a programming header, you can set it up here and easily connect it to a programmer, then take it back out and just solder it onto the board. I have some 555 ICs here. So I'm pushing the socket down, and when I get that in there, I release, and now those 8 pins should be making contact. So if I probe on this first pin and then touch right on the chip itself, we have continuity. So that's how that works. Then to get the chip back out, we just push down again to release. SOIC 8, SOP 8 to DIP 8, Easy Programmer Adapter Socket Converter Module, 150mm or 200mm, which is the width of the chip. So you can choose your circuit board color depending who you buy it from, and if you want 150 or 200mm width. Back when I got mine, it was $1.56 for one of each of the 150 or the 200mm. I thought it would be good to have one of each, so you dock the chip in there, and then you've got breadboardable header pins. For example, looking at the packages for the AT-Tiny85, you could get this one where the width of the chip is between 3.81 and 3.99 millimeters. So 3.81 millimeters is the 150 thou or mil. So I may be interested in more of these adapters in the future because they seem very useful. This item is called accessories. I don't think I've had something like that, at least not recently. That looks like NodeMcu. Sealed in this anti-static bag, and the pins protected by this foam, which I would hope is anti-static. Lowland new NodeMcu version 3 with a CH340 USB driver and an ESP8266. I bought this, and I'm also waiting for some WiMOS D1 minis to replenish ESP8266 devices, ESP8266, CH340G, NodeMcu, etc., expansion board. I got one for $1.83 at auction, just your typical ESP8266 module. I wanted to get more of these as well as WiMOS D1 minis because they're good for things like Wi-Fi subscriber counters or wireless WS2811 or 2812 LED controllers, and I've been using up the ones that I already had, so good to have extras. So it's an ESP8266 development platform using CH340G as the USB interface, can be programmed like an Arduino, and do a bunch of IoT Wi-Fi-ish stuff. This is electronic 0805 × 3, so it sounds like surface mount parts. 0805, and in there it looks like these are 10 ohm resistors. That's straightforward enough. I know I bought these because I got them at auction for very low cost. I didn't specifically need 10 ohms, but they can be useful at times. 100 pieces resistor, 10 ohm, 0805 SMD. I thought I only saw 10 ohms in that package I opened, but I actually have 100 pieces of 10 ohm, 1 ohm, and 100 ohm from 3 separate listings where I got them for 14 cents per 100 each. But they seem to be going for maybe $1.30 or more. I'm just stocking up again on parts. And you never know when you're going to need even just 1 ohm or 10 ohms. For example, here, this TI app note analog journal regarding decoupling and filtering of power supply rails on op amps. Another technique is to replace a series inductor on the power line with a small resistor, 10 to 100 ohms, and it forms a low-pass filter with a decoupling capacitor. I'll link to this article below. We're not going to go into that now, but it's good to have parts for 14 cents for a lot of 100 parts. In case I ever need to do one of these special filtering techniques, I'll have parts on hand. Next we have noise meter times 1. And that should be a sound pressure level meter thing device measurer. Sound level meter, measuring range 30 to 130 dBA, accuracy plus or minus 1.5 dB, frequency response 31.5 Hz to 8 kHz, so it doesn't cover the entire audio human hearing range, takes 3 AAA batteries. Instructions. Device. I don't suppose it came with batteries. Nope. Gotta go find some. Okay, let's see if these are any good. Batteries are good. It's showing pretty much full power. So the min-max button cycles through a real-time display, and this holds the maximum. Yes, so if I get louder, it will hold that. Okay. Or what's this, a real-time hold? Okay, I guess I can pause. And it looks like a backlight. Oh, that could be handy. GM1352 Portable Mini Digital Sound Level Meter, 30 to 130 dB. I got mine for $12.31 free shipping. So just pulling up this random one, this one would be $13.72 Canadian. And right now, when I look at this part on AliExpress and eBay, this is pretty much the same price it keeps coming out to when you factor in if there is or isn't shipping and all of that. So that's the going rate for this one. And it's in a nicely designed enclosure. You can have real time or min and max or lock the current value on the display. Has auto power off. Has an LCD backlight. Oh, a brand. Benetech. Accuracy they claim plus or minus 1.5 dB. And it's an A-weighted measurement. Not that I know enough about this, etc. And just for fun, I'm going to use this app, NIOSH. You can choose the weighting you want. It defaults to A, so I'll leave it there. And I don't have an external microphone for this, so I don't know how accurate this will be either. Looking at this manual anyway, this is what the screen will look like. So if I understand correctly, instantaneous level is real time, LA equivalent over 1 second average, and then just the max level, I think is also the A weighted. And then there's this C thing. So there's some info on those settings. So let's just do a quick test and maybe even take this thing apart, see what's inside. So I'll try comparing the maximums. How loud is this? So this meter got about 88 dBA, and the app measured L max of 77.9 with a peak of 92. So what's inside this? So the microphone is picking up sound directionally from this end. And there's what we have inside. Battery supply comes in over here. We have a couple of things. Looks like a voltage regulator, some transistor looking stuff. Not sure what that chip is. And there's a blob of some other kind of technology. And over here, some more chips and a calibration or adjustment potentiometer. Microphone comes in right here. There's one of the chips. And it looks like we have some test pads or programming pads. Data, chip select, write, 125. I will assume this SOT23 looking part is a regulator. Of course, we don't know what this is. TP7660, is that a negative supply generator? HEF4052. And this chip down here is the same as this one, but I can't get it zoomed in because there's a shadow here. So if we look on the other side here, the board just clips in with a clip on each side. And we have our display and buttons down here. So we have our backlight and our zebra stripe here, which connects down there. These buttons make contact on these pads. If I put the batteries back in, power it up, turn off the ambient light, there's our backlight. So I can turn that on and off by shorting those pads. Neat. And after reassembling, it still powers up. All right, backlight, yep, everything's good. Light bulb diodes. No, those are not LEDs, but they do look like diodes. I can't really see a marking on either side of these, but I think I ordered 1N4148 surface mount for PCB design purposes. Let's check and see for sure. 200 pieces 1N4148 switching signal diodes. I got mine for $1.52, no shipping. Let's just pick one of these. These are surface mount diodes. I may have some PCB projects coming up where I use little switching diodes, where mainly so far I've been using power rectifiers, Schottkys, so signal diodes, good to have for upcoming projects in 2020. So there's today's items, some restocking of modules and parts, some accessories for getting access to program surface mount chips before soldering them into a circuit, and a sound level meter. Whether or not it's totally accurate, as long as it's repeatable, like if I measure 70 or 75 dBA one time and that's a good level, as long as I can use that same target the next time, even if it's really 85 dBA, as long as this helps me get set up, that will help me figure out the noise levels for good audio recording. So thanks for watching. Special extra thanks to Patreon supporters who help make all of this possible. See you on the next video.